Okay, I'm going to give a little help on how to tackle the prime number problem. The prime number problem is a pretty challenging first problem for this looping unit, but obviously you need to use a loop to solve the problem. Prime number, just to remind you, is a number that's divisible only by 1 and itself. So one plan could be to get a number and try to divide it by 2 and then 3 and then 4 all the way up to the number itself, not quite, like -1. So if we take that idea and we could check if there's a remainder. So first of all, how do you check if there's a remainder? You could use the modulus operator. So you could try to do, let's say the number is, I don't know, 10, right? Then we could do 10 mod 2, and that gives us 0. So we could conclude that that number is definitely not a prime number. If we had some number like 11 and we mod that by 2, we would get 1, because 1 is the remainder when you divide by 2. Now, can we conclude that this number is prime? No, we can't conclude that right away because we haven't tried other numbers. It's true that it is prime, but let's try, in the case of 9, is a good example. If we say 9 mod 2, well, that has a remainder of 1. And we can't conclude it's prime. We know it's not prime, so we'd have to try and go again, 9 mod 3, and there we go, it's 0, so we know it's definitely not prime. So if this is the approach that we want to take, I would suggest that you, first of all, assume that it is a prime number and try and disprove it. Because, as we saw here, just because it wasn't divisible by 2 didn't mean that that was a prime number. You had to keep trying and trying higher and higher numbers, and one approach is to go all the way up to the number -1. So this could be possible. This is one possible approach that I would take, and if I just erase this, let's put some more formal pseudocode down here. Now, you know, 1 is not prime by definition, so what we could do is we could make a Boolean variable and call it is prime. And we'll set it, like I said, let's assume that it is prime. So let's set it to true, and in a loop we can try and disprove that. So we could say, maybe in a while loop, because we don't know how many iterations, we could make an integer called divisor and set it equal to 2 to begin with. And we could say, while divisor is less than the number, I also should make a variable called num. Squeeze that in there, int num equals, let's say we made an input, next int. Okay, so we get a integer. Keep going while the divisor is less than the number. That would mean it would go up to number -1. In there, we could do that test if the number mod divisor, thing we're trying to divide by, if that thing equals 0, well, then we know for sure that it's not prime. So we can say is prime equals false. Now, the thing that a lot of people want to do is say else it's true. But if you do that, then there's no point in even looping, because either way it's going to override what you had last time, right? So you want to set it to false, and then you need to get out of the loop, or else the next time it could change, right? So we may as well just break out of here. We don't need an else. Just break out curly brackets, and the rest of the process here is, well, if it were a number that was prime, like 7, and we get that number and is prime is true, it's going to, I forgot to increment the divisor too. So in here I need to say divisor.